Okay, so we got the first practice question. So with this one, we're saying a car with speed v and an identical car with speed 2v both travel the same circular section of an unbanked road. If the frictional force required to keep the faster car on the road without skidding is F, then the frictional force required to keep the slower car on the road without skidding is something. So we're thinking about, hey, if we increase our speed, how does our force change accordingly? And in this conditions, we're thinking, or actually, I'll let you pause it. So pause the video right here, try this one out, and then we'll talk about it. So yeah, so give it a quick pause, try it out, and then we'll talk about it together. Okay, so we're thinking about a situation where we really have a lot of the same ideas, the same setup. The only difference is going to be the speed, because if we're thinking about this, both of these cases, it's the same road. This is my road from an overhead view. But so both these cases, it's the same road. So if we're thinking about the variables that are changing, and we have this centripetal force equation, we know that we have this equation that says F equals mv squared over r. And in this case, we talked about it a little bit above, where we said, well, when we're dealing with a car on a surface, the centripetal force is really just the friction. And they're saying the frictional force is the only centripetal force that we're focused on. So if we're looking at this case, we're not changing the mass of the car, and we're not changing the radius of the road. So really just thinking, how does F and V and the speed, how do those relate to each other? So I'm going to set it up in a little bit more mathematical way. Maybe you're looking at the equation right now and you're just like, oh, I see what's going on. But so what I'm going to set up, because I like doing this when I think about these changing situations, I'm going to say I have case number 1 and I have case number 2. And case number 1 tells me that my car is moving with a speed of v, and it tells me that I have a frictional force. Oh no, sorry. I'm going to call this slower and faster. So this is my slow. This is my fast. So it says if the frictional force required to keep the faster car on the road without skidding is F, then the force to keep the slower one on is something. So what I'm going to set up is, again, I like to kind of do this more mathematically and say, well, I know that my equation for centripetal force is F equals mv squared over r. So with my faster car, I can say F is equal to m times 2v squared over r. I can then have to remember that I have to square both of these in here. This 2v is what I'm plugging in for my speed, so I have to make sure that I'm squaring all these quantities. So I'm going to say F is equal to 4 mv squared over r. So this is my equation for F. So F equals 4 mv squared over r. So now I'm going to look at my slower situation. And let me make this all blue for slow. Not that blue is like, I don't know. I don't think of blue being slow, but whatever. Okay, so like red is definitely a fast color. I guess blue is kind of like a slow, like, you know, just like rivery, I don't know, whatever. All right, so we're looking at what is F slow. So we're going to set this up and say F slow is equal to the same mass, same r, and it says we're moving with a speed of v. So we can plug in v squared. So it looks like F slow is equal to mv squared over r. And if we're thinking about comparing and kind of plugging in F, we can say that F is equal to 4 times this mv squared over r. So we can kind of, if we do want to do it a little bit more mathematically, we can manipulate things around a little bit and say m over r is equal to F over 4, or sorry, we can kind of sub in, so we can set up a situation that says mv squared over r is equal to some fraction of f. And we can do that because m is going to be the same, v is based on the same number, and then r is going to be the same. So what we can say then is if we look at this equation, we have Fs equals mv squared over r, and we've set up our equation for f in terms of mv squared over r. So we can say this is really equal to f over 4. So we can say Fs is equal to f over 4. So the slower car has about a quarter of the friction needed to stay on the road as the faster one. So our force of the slow car is a quarter of the force for the fast one.